Alright, let's talk about quicksort. So quicksort is pretty simple. You just have a pivot, and once you have a pivot, you have to traverse the remaining um on your left, and this will just comparing. So you have to compare your pivot, and which is fulfill. You have to swap, right? So 26 is actually less than 31, so you swap, right, with 35, and swap, swap, and again 42 and 19. Just look at the definition below. You'll swap 10 and 14, which is good. And then you'll swap with this because 31 is actually stored in this index. Right. And then you partition on your left, partition on your right. So this is pseudocode. Maybe I can just copy and paste and then go by my code. So this is in array and it's original array, and I will call my quick sort, printing out my sorting array. Right. So what I did is copy paste. Okay, I didn't copy. Go. So choosing the highest index has pivot. So I'm calling my index sort array low high, right? And this will be what you will have to have a low less than high in my index is correct. And I will have a pivot, right? Pivot partition and array low high. So once the pivot is already sorted, then you just have to traverse on the left and traverse on the right. So I would just call sort array low pivot -1 sort array pivot plus 1. I think there's no question when I given these two uh three lines of code, because this is pretty straightforward, and they just dive into the partition. So you need to have a pivot in the partition. Again, pivot will be, I would just call my pivot on the highest index full array, and take two variable to the left and right, exclude the pivot, right? So basically it's this. And left pointer point to a low index, right pointer point to a high, right? So this is tricky. I'm going to set the index, which is low. So low -1. I will using low -1 because I will just exclude this index value. When I traverse, I starting from low to high. So look at this. When I traverse the array from the left, and go back to the diagram on the left, right? And then I need to fulfill the if statement. If my pivot value is actually greater than the current I, this is actually my I, and I will just increment my index and swap with it back to here. So if my pivot is actually greater or equal to array I, so array I is starting from a low, and I'll increment my index, and then I will swap my index with, so I and index should be familiar. They're actually the two pointer, and they also started from the low, but one started from low -1, the other one started from the low. So if the pivot is actually greater or equal to the array I, then you swap. And after that, you need to swap your pivot index. And your pivot index is actually high, right? This is actually your index, right? And the index is where you actually need to keep track on your pointer. So look at this. At the end, 1942, 10, 14, and then you know high and low, you have to swap, right? This is the index you need to swap. And 31 will be fixed in the array. So whatever you do, swap, array, and pivot. Pivot is what? I, and what? Index +1. The reason why you have index +1 is because whatever whatever you swap on the left is actually less than your pivot. And index plus 1 is because the pivot is actually greater than the index, array index. So you have to swap with it. And then you have to return index plus 1. This is your pivot. And this is partition at the end. So let me just dive into it. So choosing the highest. Yes, I'm choosing the highest. Taking two variable to the point left and right. Yes, I do. And left pointer to the low. Yes, I do. And right pointer to the high. Yes, I do. And which value at the left is less than point to the right. Which value at the right is greater than the pivot to the left. So basically it's like this. You are swapping. So I was just using one pointer for sure. I'm not just using, but you can use 2 pointers, whatever. And after that, you need to swap the pivot on the left and right. So pivot on the left and I believe it. So they just run it. So this is pretty. This is original sort. Original array, and this is sorting array. So this is actually working. And if you not believe it, you have to go over. You have to back to the site and in this example, this basically using 2 pointer. I'm not recommending because you get too complicated. And yeah, look at it. This is quicksort pseudo code. And let's back to the complexity for the quicksort. The worst case n squared. The average case unlock n. The base case unlock n. Base is constant. Table is null. This is because when you have a duplicate, right? Duplicate integer in the array, you don't know which one to go first. And the method is actually divide and conquer, so which is partition. So this is pretty much it. And there's a quick note. So why quicksort is better than merge sort? You have to explain to your interviewer if they ask. So quicksort is a in-place sorting method and does not require additional memory. And I will talk about merge sort later, but indeed, base complexity is constant, all of one. And pretty much it. I will see you next time. Bye.